Dr. Johnson has been talking about a way of, we all have our own views about what reality really is. I mean, the real thing is charge, or the real thing is energy, or the real thing is fields, I don't know. And everybody, I found that most people in this room have a pretty strong feeling about what they think reality is. Dr. Johnson is presenting an idea that's maybe saying maybe none of them. Maybe, I don't know what the ultimate reality is, but it does make it difficult. And although he's going to be talking about physics, it does sort of fit in with our philosophical section, because it makes you think. I mean, we do need to sit down and question what is the ultimate thing that we call reality. So, and I just wanted to put in a plug. You didn't bring your books with you, did you? Well, you did. Oh, okay. He's got books, which and several other people have books as well. Real interesting books on just, I guess, kind of the whole metaphysics of this process that we're going through as scientists and trying to figure out what reality is all about. And in looking at the world through the eyes of Tesla Tech people, looking at the world through the eyes of mainstream science, there's something valuable to be found from all of them, and yet none of them are completely 100% right. So anyway, I won't take any more of your time. Dr. Johnson, come on up.
Yeah, thank you, Greg.
The bottom one is, there you go.
Since it's my first time here, I give a little introduction to myself. Could we turn off the light over there, make it look better? Back in 1954, sophomore in high school, ham radio operator, interested in antennas, radio wave propagation, reading the books that people had written to ham operators, and I knew intuitively that they were wrong, and also knew intuitively that I needed to go to college and try to figure out what was the real basis for antennas, radio wave propagation, and the like. So, changed my career plans to being a farmer like my dad. Took freshman algebra as a junior, sophomore geometry as a senior, went to Kansas State, got a degree in electrical engineering, and went on for a couple other degrees. Back to Kansas State, taught electromagnetic theory for 28 years till I took early retirement. And after I retired at age 55, I was a midwife for a large wind farm in southern Kansas. Collected wind data, wrote the reports, advocated for the rancher to the money people, utilities, and the like. So I've been a dissident for a long time. So I have a pretty extensive library of all the strange stuff I've subscribed to. Read Infinite Energy from the beginning, a pretty long section of the bookcase of Galilean electrodynamics, and so on. So into the talk, what did I teach my students in electromagnetic theory? Or maybe not as much on the first one, but that was done in sophomore engineering physics. But I would agree with the mainstream thought an electron has mass. A very well specified number. You look in the back of your sophomore physics book, and there it is. Mass has a gravitational field, something Newton wrote down once upon a time. No limits on the extent of it. So we'd say that the electron has a field, gravitational field, that extends to the edge of the universe. And then I'd also teach that electron has charge, and the Coulomb field, electric field, extends to the edge of the universe. So you look at those statements phrased like that and you say, really? We talk about the ether, and there have been as many proposals for an ether pervading space as there are people to think about such things. And this would be a form of ether. Anything that fills the space that somehow causes other things to happen or allows things to happen. So I look at those statements and the answer, really? Well, I'm not so sure, okay? So I've been staring at this blank piece of paper. How did God put all this together in the first place? Or how did the Big Bang cause things to happen? What do we have really? And so wrote down these concepts. So what if there is no mass stuff, no charge stuff, no electric, magnetic, or gravitational fields? Now, the idea of field, Thomas Phipps has been eloquent on this, presenting the fact that we really don't see fields. What we see are forces. And we use the concept of a field to explain forces. So it's a model. The whole notion of electric field, magnetic field, gravitational field is a model, a mathematical model, gives the right answer. And so those of you that are going to grab me by the collar afterwards and say, look at, this works. I agree, works. But the fact that it gets the right answer does not prove that it's the way things really are. So, given those statements, say, what do we have? Well, we have energy. No mass stuff, no charge stuff. We have just energy. That's not a new concept. Max Planck said that when he received his Nobel laureate. Something basically like it. Some of the world's religions basically say that. So any idea that equal mc squared, that we tend to think of mass being real and energy determined from mass by multiplying by the appropriate constant. Well, I guess I'm turning it around. I'm saying the energy is real and the mass is something that is equivalent or somehow can be determined from the energy. So you have mass-like particles, mostly stable concentrations of energy. I don't have a good picture for you of how the energy looks, how you draw it to make a good picture of it, but as you think of an atom, a nucleus, electron swinging around it, there's energy involved there. We have some kind of a mental image of fields and all that to accommodate separations and motion. Well, I just say that the whole thing is a concentration of energy, that there's really not any specific little chunk that's mass and another little dab of something that's charge. It's just all energy. Well, if you don't have fields, you need something else, and so I'm saying information. Now that might be something new or newish or not developed as fully as the idea of energy. So just continuing to think about the what if of all this. Say, okay, we have information. It'll travel through space. A packet, parcel, bundle, some kind of a structure maybe. And if you want to coin words, call it an infoton. Along with that idea, it would make sense that we can have energy throughout space that hasn't been formed into mass-like particles or into something that our field detectors could detect, which would imply that T. Henry Moray was correct. We read the sea of radiant energy and the equipment that he developed back in the 20s and 30s to extract energy from the ambient. And so that would suggest that there really is zero-point energy, which relates to some of the work of some of you in this room, I'm sure. Okay, so when you say, well, without fields, how do we get force? So I'm saying that force on a mass-like particle is observed when the infotons on and in the particle cause the mass-like particle to give up part of its energy in a specified direction, analogous to a spacecraft making a mid-course correction. Okay, so you think about this a little bit. We have a spacecraft heading off to the moon or wherever. We discover that it's not quite on the right trajectory. We send a signal telling the spacecraft, turn on your rocket in a certain direction for a certain period of time, providing a certain force in a given direction to correct the trajectory. We don't try to control that spacecraft with a field, electric, magnetic, gravitational, that just goes out everywhere. We do it with information and a small amount of energy that's contained in the spacecraft in the form of rocket fuel, propulsion, whatever you got in the spacecraft. So the whole idea of forces, gravity, this would be a new concept for gravity. And I appreciate that some of you in this room have thought deeply about gravity, and I don't want to tread on anybody's toes here. It's been my observation that we have four major concepts of gravity. Gravity is the pull, engineering physics, the standard force of the gravitational field, the concept of a pull. Warped space from Einstein, somehow things fall due to space being warped. Far action, that actually was Newton's concept of gravity, and then Peter and Neil Grinnell, a father and son team, dealt with this extensively. And gravity is a push, where you have some little particles, gravitons call them, traveling through space at high speeds, maybe up to 10 to the 10 times the speed of light, and they hit things and they push them toward each other, and then do some shielding where all the first four give you the right answer. They work. But you look at the four concepts and you say, wait a minute, given that there are bright people, knowledgeable people, people who have been to school, and the gravity is a push. I have a fairly recent book, 27 articles of knowledgeable people, different aspects of this theory. So you say, well, here's four quite different explanations of gravity, what does that say about how, do we really know what gravity is? We'll sure find out a little more this evening with the gravity interest group. It's like, how do you cure a wart on your foot? So you go to the internet, you look up Mayo Clinic, and they give you 6 different methods of fixing this wart on your foot. And one of them is duct tape. Okay, well, when the big boys give you 6 different ways of fixing something that looks like it ought to be easy to fix, that means that nobody knows, in my opinion. Okay, well, I would add one in my theory that gravity is a directed energy expulsion. You've got this Masslike object, and it's told by its information to give up some energy. I realize there's some aspects of how do you get the energy back in, and maybe the 0-point energy interacts there somehow. Obviously, I don't have things put together too well on this. But let me move on to my main interest in all this. How does energy get down a transmission line? So it's something I taught my students a lot of times over the years. You have a source on the left, battery in this case. You have a switch. You have 2 wires that carry a circuit, carry a current, and a resistor at the far end. You close the switch, current flows, power flows down the line. Now, as you may or may not be aware, electrical engineering has a number of subdivisions, 2 of which are circuit theory and EM theory. Circuit theory says that obviously power flows in the conductors, in the wire. There's voltage, there's current. Current is electrons bumping along somehow in the conductors. And so things happen in the wire. The EM theorists, on the other hand, say, no. Obviously, power flows on the outside of the wire. We have electric field, magnetic field, there's Poynting vector, power flows on the outside, a little bit bleeds off into the conductor to heat it up, but power flows on the outside. Well, think about that and say, wait a minute, one of the 2 groups, at least, is wrong. Okay, power either flows inside or outside, or maybe some unknown third thing. But the thing about electrical engineering is we've agreed to disagree amicably. And the students never pick up on this problem. In a circuit theory class, obviously power's on the inside of the wire. They walk down the hall to an EM theory class, obviously power's on the outside. Something goes clunk in their head walking down the hall, and it all works. Okay. Well, with the concept of information here, let's explore this just a little bit. Somehow, in this theory, when the battery was put together, when it was attached to a circuit, this chunk of information showed up. And I don't have a good explanation of how it got put together or anything like that. Just that it's there with the battery. It's basically the equivalent of DNA in a cell. If you're growing an oak tree from acorn, you've got information in the seed, whatever the plant is, and somehow it starts the process of things growing. So DNA for humans and other critters like ourselves. So the infoton is in that category of things. And the information then causes the field structure to take its form. Now I'm using the term, I said there isn't any field structure. Well, there's energy that takes structure that our instruments will interpret as electric field. So somehow the information causes the energy structure to expand out from the battery to fill the surrounding space, and we would interpret that energy structure as, the blue part would be an electric field. Switch is open, so there's no magnetic field, no current flow, but there is energy there, energy that we would interpret as electric field. Okay. We close the switch. Now we have energy moving down the conductor. So we still have some electric energy, electric field energy, or energy that our instruments interpret as electric field. So we have voltage on the wire, but we also have current. So we have a magnetic field that our instruments detect as current. So the blue would be electric field, the red would be magnetic field. And so that conglomerate, that structure of energy is now moving down the conductor. There are certain, it's like the infoton, the information has told it how to structure itself, what kind of ratio between blue and red, how much energy is in the blue, how much of it's in the red, how fast it's going. Now the speed of that, what we might call a photon, moving electromagnetic energy, usually think of photons as out in free space, but we might allow that word here on the transmission line. So it's moving down the line at the speed of light in the surrounding medium. Well, this is one of those other interesting things about the stuff we teach to our students. Page 100 of the book talks about the speed of electrons in the wire. Basically, electrons move in a conductor at about the speed of a person walking. Okay? In fact, I can walk faster than electrons migrate down a wire. Okay? Very slow. So that's page 100. Page 200, we've got this situation, and now energy is somehow traveling down the system at the speed of light in the surrounding medium. It's not determined by the conductor, it's determined by what stuff is around the wire. If it's air, it's speed of light in air. If it's polyethylene, it's the speed of light in polyethylene. So how does an electron know to move the speed that something happens outside the space where the electron is? That's one of those questions that I don't know that what we do as teachers at that point is we raise our voice, we wave our arms, and we move on. I had one student, most of my students would sit there frantically, look at what I was writing on the board and try to copy it down. And one student would sit at the back of the room and watch. And when he raised his hand, I knew I was in trouble. He could pick up this sort of stuff easily. So we have the energy flow down the line. The infoton, the little dot in the middle, causes the structure to change as the characteristics of the conductor changes. The impedance, that Z0 thing. It's true you have a battery, and so the wires have zero resistance, ideally. That's not part of the problem. Actual resistance you deal with separately. But it has a characteristic impedance determined by capacitance and inductance, and, the ratio, square roots, and all that. And so as you go from the battery, the wires connect to the transmission line, the wire sizes change, the distance between them changes, characteristic impedance changes, the ratio of electric field to magnetic field for a given amount of energy changes. So the infoton would somehow be tracking all of that. That somehow it would sense, determine how big are the wires, how far apart are they. Given that information, I need so much electric field, so much magnetic field for this to work. Somehow the infoton senses the material, polyethylene or whatever the dielectric is. And so the speed is this much. So I guess maybe some of you have seen this concept where we have energy and information. And if you have, I appreciate the information, the reaction to it. But as I look at it, this seems like a reasonable approach. And even if it's totally wrong, it gives us a new way of thinking about some of this stuff. As I look at transmission lines, how is it that parcel of energy is able to go down the line, keep track of the ratio of magnetic to electric field, keep track of the right speed, give up its energy to that resistor uniformly? It doesn't all dump at one end of the resistor or both ends. The middle is still cold as the energy. No, it all dumps uniformly over. Well, that's looks to me like something there has some capability of keeping track of that. How do you heat things up to make it all come out even? So, obviously, it's an interesting concept to me at least, and a great deal of work to be done. I'm obviously thinking about it, and if I get some suggestions from you all, I'd appreciate it. So, thank you very much.